Welcome to Time to AI, I'm Jason Turpin. Today's video is technical and will cover an implementation of a basic research assistant. This isn't a chatbot, it's an application that you run and then make coffee or use the restroom while it does its thing. The assistant will take a topical request, consider it, retrieve related internet content, and finally summarize the information to fulfill the request. This is similar to how ChatGPT or the Copilot chatbot access the internet, but this gives a bit of a wider perspective, and it takes longer as a result. This is a very basic researcher. Future videos will extend to the capabilities and result quality. Anyway, this basic researcher will involve 2 LLM API calls, usage of a SERP search engine service for Google search results, and calling the Python request library to fetch internet content. All the code is available via the link in the description. Let's do this, Leroy Jenkins. First, let's pick a research topic. Water is a pretty big global issue, so let's use current US aquifer issues. That's a pretty good search phrase to use in Google to find articles. It works pretty well in ChatGPT or Copilot as well. We'll compare those results at the end. But the researcher needs to look farther than a standard internet search. This is done by performing multiple related internet searches to approach a particular topic from different angles. We will use an LLM call to come up with those search phrases. Here's the prompt. Below is a research topic. Please generate 3 internet phrases that provide a comprehensive base for obtaining information about the topic. Pay attention for global filters such as geographical, an individual name, or a particular time period. Let's try the code for just this. So here we are in the code, and here's the process I described. We're gonna get Google search phrases. We're gonna use a SERP service to get search results, like what are the web pages related to that search. Get the web content, and then we're gonna summarize it. Right now we're interested in the Google search phrases so let's go ahead and run this. Up here we've got my topic, current US aquifer areas. Just going to hit F5. We're gonna look at the code in here. So we're going to F11 to there. So this is all it does right here. This whole thing right here. So there's a prompt here. So this get searches prompt looks like this. We're researching a topic. There would be formatting requirements. Ignore that. Consider the topic and aspects and what other ancillary information would be used. It's not exactly what I was reading earlier, but it's similar. And then a little bit of cleanup, because of what happens when you get a LLM response that's returned as JSON, it's got little markers around it. So we're going to go ahead and run this and get the Google search phrases. So that's finished, and now we have our search phrases. So I passed in current US aquifer issues and asked it, give me different ones that are related. And so I came up with these: current US aquifer depletion challenges, causes of aquifer contamination, and solutions for sustainability. It just came up with those. And that's what I wanted to do. I wanted to come up with alternative search phrases that kind of give a wider perspective on the topic. So now we have our search phrases. Let's call the SERP service to fetch the results. SERP stands for Search Engine Results Pages. SERP providers expose API endpoints that perform various internet searches against Google, Bing, or other search providers. You can choose to search against a main search engine, search for news, other features, search by date, language, all sorts of options that really give you a pretty good interface into Google and other search engines. So let's take a look at this code. In this case, I'm going to fetch SERP results for those search phrases, and I'm going to get 2 results each back. That's flexible. In this case, I asked for 3 search phrases. I'm getting 2 results back. I can have the opportunity to have up to 6 unique URLs. So let's go ahead and take a look at this one. Again, it's a very short method. There's the whole entire thing. I have a method called get Google search results, which we'll take a look at that real quick. That goes in and sets up parameters and makes an API call. Again, I'm using value SERP. I like them personally because they provide consumption pricing, where most services have monthly fees, and as an individual I prefer consumption based. And so that's what this does. I'm just going to F5 and let it run all this, and it's going to basically make the SERP calls. And you can see right there, performing Google SERP search for those things. There it goes. I'm going to do that. There we go. Now if I go to my URL list here, I've got 6 URLs, and I got titles, and there's links in there associated with those. Now that we have the custom search phrases and internet search results, let's get the pages using Python's request library. We've all used beautiful soup to remove HTML and perform some other minor cleanup to remove as much cruft as we can so that we have more of the core content. You still have things like ad sections and menu sections and things like that show up in there, but the LLM is smart enough to ignore that because it's also given instructions to do so. So what does fetch and clean web content look like? Let's go into there, let's step into it. Again, this is very basic. That's the entire method. All it does is go through the result, gets the link, make sure it's skipping PDFs for now. That's a feature we'll put in place later. Uses request, sets a user agent, grabs it, does a little bit of cleanup, and the cleanup is very basic. Cleanup just uses beautiful soup to get the text. That removes all the HTML elements, reduces the size of the package. It does include, leaves all the cruft at the top and the bottom, the header and footer information, call it, and then does some basic cleanup on just remove some duplicate stuff to clean things up. So I'm gonna hit F5 and let this run. And see here, it's going out and it's getting each of the URLs. I'm gonna let that run for a few seconds while it does that. Okay, now here we are in our main loop again. We've gotten the Google search phrases, we've got our SERP results. Now we have our clean web content, which looks like this. It's a big block. Let's see, length of web content. 490. This is interesting because we're going to run into a situation that I'm going to talk about. Let's go into the code here. Let's talk about this. Here's the core thing right here. Below is a set of web content. Please fulfill, it's filling there, the research request to the best of your abilities. Cite references in line or at the bottom, whichever makes sense. That's the actual entire request. Above it, this is a call to fact, request for truth. And the stuff at the bottom, found this on an article, a great article. I'll include that in the links in the description. But it's designed to have it produce more natural results that don't sound like AI. So before we run all this, let's think about the LLM's context length and sending over a bunch of web content. It's very possible, in fact it's happening, that the length of the web pages combined will exceed the LLM's context window. So we just checked, we have 490,000 characters. That's going to be more than that's going to be more than the context window can take. And how do we deal with that before we get here? Inside my call Azure OpenAI prompt method, let's go look at that. I have a thing right at the very beginning. It says the prompt is too long, and I'm setting my token limit at 80,000, and a token is 4 characters. So I multiply that by 4, and then I just truncate it. So it should note that it's truncating it when I do this. And so we're going to let this run to the next step. And we'll address this truncation later. There's better ways around that. Don't want to give away those secrets quite yet, though. So let's let this run for a moment and see what happens. It's already finished, actually. Let's see what it did here. There we go. Groundwater depletion, it's pretty good. Talks about what it is, what it's caused by, negative effects, lowering water table, reduction of water in streams, pumping costs go up, deterioration of water quality, regional examples, the High Plains Aquifer. I don't know how to say that, but that's the one I pay attention to the most. It's talking about the regions and some of the problems by the region, global perspective, and if I go back to my code real quick, we should see in here, it truncated the prompt to 320,000 characters, so it removed 170,000 characters from there, which is fine. Let's take a look at what ChatGPT and Copilot do in this situation. Current U.S. aquifer issues, ChatGPT. You see it searches the internet right there. It's searching there. It's thinking about it like my little researcher. Facing serious depletion, climate change, regional variability. And you notice this doesn't give a whole lot of detail. Mine is longer, provides more detail. In my opinion, I guess they're given references here in line. And you see there, I'm pulling from USGS and Nature.com, and they're pulling from Democracy Now! And a couple of different websites. Let's try this with Copilot. What I will say is that I like the research results that I got better than ChatGPT, because it's doing a little bit more, I'm going to call it thinking. It's considering the topic a little bit better manner, I think, or a little more expansive manner. Up here for Copilot, we get, it's currently facing significant issues, depletion, impact on agricultural development, river flow reduction. It's interesting. But anyway, folks, that's it. It's a basic AI-enabled internet researcher. Reviewing the breadth of data, it generates 3 unique internet searches, each returning 2 results. So there's a maximum of 6 internet results. These numbers can be changed. They can go higher. It results in more content, which of course is going to lead to that truncation. And if you think about it, that truncation is going to cut off anything extra. It's going everything in order, and now it's just cutting it off. PDFs are ignored, and also not all web pages work with the request library. And a lot of times they just won't return just because they're trying to avoid bots and stuff. In my experience, you'll get 3 to 6 of these results are generally available just using a straight request call. After that, it performs those searches to grab the information and summarizes it. And that's about as basic an internet researcher, that's AI enabled at least, that you can do. And that's also the end of the video. I hope you found this informative and educational. The next video will be an expansion on the researcher to address some of the issues we've been seeing, particularly around truncation. Anyway, like and subscribe, and until next time, have a good one.